Students, welcome to new episode, and in this session we will see the problems on basic proportionality theorem and the converse of basic proportionality theorem. Here is the first question on the screen. M and N are the points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether MN parallel to QR. Here it is said that MN is a line segment intersecting the two sides of the triangle PQ and PR at M and N respectively, and we have to state that MN is parallel to QR with the given conditions that PM is equal to 4 centimeter. It is given that PM is 4 centimeter and QM is 4.5 centimeter. Then PN is 4 centimeter and NR is 4.5 centimeter. Now here we will take the ratios of PM and MQ. These two lines MN and QR will be parallel when the PM upon MQ will be equal to PN upon NR by the converse of basic proportionality theorem. So we will find PM upon MQ, that is equal to 4 upon 4.5, and another ratio, and PN upon NR, which is equal to 4 upon 4.5, and since this ratio is equal to 4 upon 4.5 and this ratio also equal to 4 upon 4.5, therefore we can say that PM upon MQ, which is equal to PN upon NR. Therefore, by converse of basic proportionality theorem, we can say that MN is parallel to QR. Here is the another question. M and N are the points on the sides PQ and PR respectively of triangle PQR. For each of the following cases, state whether MN parallel to QR. Here in this triangle PQR, M and N are the 2 points on the sides of a triangle PQR on PQ and PR respectively, and we have to show that MN is parallel to QR given that PQ is 1.28 centimeter, PQ is 1.28 centimeter. This total length or the side PQ of the triangle is 1.28 centimeter. PR, this total length is 2.56 centimeter, and PM, this is the PM is 0.16 centimeter, and PN, this PN is 0.32 centimeter. Here PQ is equal to PM plus MQ. This total length PQ is PM plus MQ. PQ is 1.28 centimeter, which is equal to PM is 0.16 centimeter plus MQ that we do not know. So MQ will be equal to MQ, that will be equal to 1.28 minus 0.16, and which is equal to 1.12 centimeter. Similarly, NR, PN, this PR will be equal to PN plus NR. Similarly, PR which is equal to Pn plus Nr. Pr is given as 3.56 centimeter, which is equal to, sorry, this is 2.56 centimeter, which is equal to Pn is 0.32 plus Nr that we do not know. Therefore, Nr, which is equal to 2.56 minus 0.32, and therefore Nr is equal to 2.24 centimeter. So here we have got MQ, that is equal to 1.12 centimeter, and NR, that is equal to 2.24 centimeter. Therefore the ratio PM upon MQ, that will be equal to PM upon MQ, that is 0.16 is PM and MQ is 1.12, so which is equal to 1 by 7. And now Pn upon Nr, so Pn upon Nr, that is equal to Pn is 0.32 upon Nr is 2.24, which is equal to 1 by 7, and therefore Pm upon Mq is equal to Pn upon Nr. Therefore Pm upon Mq, which is equal to Pn upon Nr, and since these ratios are equal, by converse of basic proportionality theorem we say Mn is parallel to Qr. Therefore by converse of basic proportionality theorem, Mn is parallel to Qr. Other question is, in the figure DE is parallel to BC, find EC. Here in the figure triangle ABC is given and it is said that DE is parallel to BC, and it is also given that AD is 1.5 centimeter, DB is 3 centimeter, AE is 1 centimeter, and we have to find EC. So here the given dimensions are AD, which is equal to 1.5 centimeter, then DB, which is equal to 3 centimeter, and AE is equal to 1 centimeter, and we have to find EC. Since DE is parallel to BC, this is given, we can say that AD upon DB is equal to AE upon EC. Since DE and BC are parallel, by basic proportionality theorem we say that AD and DB, AD upon DB, this ratio is equal to AE upon EC. So this is by basic proportionality theorem. So AD is 1.5 centimeter upon DB is 3 centimeter, which is equal to AE is 1 centimeter, and EC that we have to find, and therefore 1 upon EC, which is equal to 3 1s are 3, 3 5s are 15.5, so 0.5, and therefore EC is equal to 1 upon 0.5, so EC is equal to 10 by 5, 5 2s are 10, so EC is equal to 2 centimeter. The next question is, in the figure DE is parallel to BC, if AD is equal to x, DB is equal to x minus 2, AE is equal to x plus 2, and EC is equal to x minus 1, find the value of x. It is given that ABC is a triangle and DE is parallel to BC. It means this DE is intersecting the two sides of the triangle and it is parallel to the third side, and it is given that AD is x centimeter, then DB is x minus 2 centimeter, and AE is x plus 2 centimeter, and EC is x minus 1 centimeter, and we have to find x. Since DE is parallel to BC, then the ratio AD upon DB will be equal to AE upon EC. Here it is given that AD is equal to x, DB is equal to x minus 2, AE which is equal to x plus 2, and EC is equal to x minus 1, and it is given that DE is parallel to BC, and therefore AD upon DB which is equal to AE upon EC by basic proportionality theorem, and therefore AD is x upon DB is x minus 2 which is equal to AE is x plus 2 upon EC is x minus 1. Therefore we will solve this further. So cross multiply x into bracket x minus 1 which is equal to x plus 2 into x minus 2. So here multiply by x inside the bracket, so x square minus x which is equal to here a plus b into a minus b, and therefore it will be a square minus b square, so it will be x square minus 4. Here x and x will get, x square and x square will get cancelled, minus x is equal to minus 4, and therefore x is equal to 4. The required value of x is equal to 4. Next question is, prove that the line drawn from the midpoints of one side of a triangle parallel to the another side bisects the third side. So here it is given that in a triangle ABC, D is a midpoint of side AB and DE is parallel to BC. It means that DE intersects the two sides of the triangle and it is parallel to the third side, and so here we can apply the basic proportionality theorem. So first we will write the given things. Given in triangle ABC, D is a midpoint of AB and DE is parallel to BC, and we have to prove that E is a midpoint of AC. That is, we have to prove AE is equal to EC. So proof: in triangle ABC, D is a midpoint midpoint of AB, and therefore AD is equal to DB. This is given. But DE is parallel to BC, DE is parallel to BC, this is also given, and therefore AD upon DB, that is equal to AE upon EC by basic proportionality theorem. DE is parallel to BC, and therefore AD upon DB is equal to AE upon EC. This is the basic proportionality theorem. But here AD is equal to DB, let this be number 1. AD is equal to DB, so if we replace DB by AD, then this AD will get cancelled and we will get AE upon EC, that is equal to 1 from 1. And take AC to the other side, and therefore AE is equal to EC, and therefore E is a midpoint of AC, and therefore E is a midpoint of AC, and so we can say that a line drawn from the midpoint of the one side of a triangle parallel to another side bisects the third side. Another question is that prove that the line joining the midpoints of two sides of a triangle and is parallel to the third side. It is given that ABC is a triangle and D and E are the midpoints of the sides AB and AC, and we have to prove that DE is parallel to BC. So first we will write given in triangle ABC, D is a midpoint of AB, D is a midpoint of AB, and E is a midpoint of AC. And to prove that DE is parallel to BC, this we have to prove. So the proof will be DE parallel to BC, that we have to prove, and here it is given that D is a midpoint of AB and E is a midpoint of AC. Therefore we can say that AD is equal to DB and AE is equal to EC. Reason: D and E are midpoints of AB and AC respectively. If we take the ratio of these two parts, AD upon DB, so AD upon DB and AE upon EC, so if we take the ratio of AD upon DB, then that ratio will be equal because both lengths are equal, and so the ratio will be equal to 1. Similarly, AE upon EC, that will be also equal to 1, and since these ratios are equal, therefore AD upon DB, that is equal to AE upon EC, and since these ratios are equal, by converse of basic proportionality theorem, we can say that DE parallel to BC, and therefore DE is parallel to BC by basic proportionality theorem, hence proved. Here is another question. In the given figure, if LM is parallel to CB and LN is parallel to CD, prove that AM upon AB is equal to AN upon AD. Here in the figure it is given that this ML is parallel to BC and this LN is parallel to DC, and we have to prove that AM upon AB, that is AM upon AB, this total length is equal to AN upon AD. So first we will write the given things. Given ML in the figure, ML is parallel to BC and LN is parallel to CD. Then here we have to prove that AM upon AB, which is equal to AN upon AD. Now proof. Here in triangle ABC, in triangle ABC, we see that ML is parallel to BC, this is given, and therefore we say AM upon AB, AM this much upon AB total length is equal to AL upon AC, this total length, by the corollary of basic proportionality theorem. So in triangle ABC, ML is parallel to BC, this is given, and therefore we say AM upon AB, which is equal to AL upon AC by corollary of basic proportionality theorem, and let this be equation number 1. Now in triangle ADC, take this triangle ADC. In triangle ADC, LN is parallel to DC, LN is parallel to DC, and so we can say that AN, this length, upon AD, this total length, is equal to AL upon this total length AC, again by corollary of basic proportionality theorem, and therefore AN upon AD is equal to AL upon AC. The reason is same, corollary of basic proportionality theorem, let it be number 2. Now if you observe the equation 1 and equation 2, the right part of the equation 1 are equal, and therefore the left part 2 should also be equal, and so from 1 and 2 we have AM upon AB, that is equal to AN upon AD, hence proved. In the given figure, DE is parallel to AC and DF is parallel to AE. Prove that BF upon FE is equal to BE upon EC. Now here in the figure, ABC is a triangle, and it is given that this DF is parallel to AE, these two line segments are parallel, and also it is given that DE is parallel to AC. So first we will take DE parallel to AC. So I remove the two lines and we get a triangle ABC in which DE is parallel to AC, and this DE is intersecting the two sides of the triangle in two distinct points D and E, and so here we can apply the basic proportionality theorem and we get BD upon DA is equal to BE upon EC. So in triangle in triangle ABC, DE is parallel to AC, this is given, and therefore BD upon DA, BD upon DA, that is equal to BE upon EC. This BD upon DA is equal to BE upon EC. This is by basic proportionality theorem. Let this be number 1. Now this is our original figure, and now it is given that this DF is parallel to AE. I remove this figure to get the clear idea of the figure. So I remove this DE. So after removing this DE, we get DF parallel to AE. So in triangle ABE, DF is parallel to AE, and therefore we can say that DB upon DA is equal to BF upon FE. Therefore in triangle in triangle ABE, this triangle, DF is parallel to AE, DF parallel to AE, this is given, and therefore BD upon AD is equal to BF upon FE, BF upon FE. The reason is basic proportionality theorem. Let this be number 2. From this 1 and 2, we say that the left hand side of the equations are already equal, and therefore this right hand side will also be equal. Therefore from 1 and 2 we can say BE upon EC, which is equal to BF upon FE. So this only we have to prove, and therefore BF upon FE, which is equal to BE upon EC, and this only we have to prove, hence proved. Here is the another question. ABCD is a parallelogram and P is a point on the sides BC and DP when produced meet AB produced at L. Prove that DP upon PL is equal to DC upon BL and DL upon DP is equal to AL upon DC. Now here in the figure it is given that ABCD is a parallelogram. It means its opposite sides are parallel and equal. Now here BC is parallel to AD. These two are parallel. It means this PB is also parallel to AD. So here given ABCD is a parallelogram, in parallelogram ABCD, BC is parallel to AD, BC is parallel to AD, and therefore BP is also parallel to AD, PB is also parallel to AD. Now in triangle ADL, in this triangle, this PB is parallel to AD, means this line is intersecting the two sides of the triangle and it is parallel to the third side. Then it divides the two sides in equal ratio by basic proportionality theorem. So we can say that PL is equal to PD is equal PL upon PD is equal to BL upon BA. So here we can say that therefore PL upon BL, which is equal to PD upon BA, PD upon BA by basic proportionality theorem. But here this AB we can replace by DC, because AB and DC are the opposite sides of the parallelogram and therefore both are equal. So we can replace AB is by DC, but AB is equal to DC, opposite sides of parallelogram, and therefore we get PL upon BL, which is equal to PD upon DC. Now take PD to this side and BL to other side. So therefore PL upon PD, which is equal to PD, sorry, take BL to this side, so it will be BL upon DC, and therefore PL upon PD, but we want dp PD upon PL, so take reciprocal of both the sides, so PD upon PL, that is equal to DC upon BL, hence proved. And therefore it is proved that PD upon PL is equal to DC upon BL. Now we have to prove that DL upon DP is equal to AL upon DC. I delete this portion to make a space to prove the second part. Now here once again PB is parallel to AD, and therefore by the corollary of the basic proportionality theorem we can say that DL upon DP, that is equal to AL upon AB. So here we can say that DP DL upon DP, which is equal to AL upon AB, AL upon AB, but AB is equal to DC, so AB can be replaced by DC, but AB is equal to DC, opposite sides of parallelogram, and therefore we will get DL upon DP, which is equal to AL upon DC, and this only we have to prove, and so DL upon DP is equal to AL upon DC, hence proved. And the reason for this is corollary of basic proportionality theorem. And students, here we will stop and we will see few more questions in the next episode. Thank you very much.